Ah, there we go. I don't know what's going on there. Okay. Sorry about that. I don't know what was going on with that. Is Twitch working now? Okay, yeah, both are up. Okay, cool. Anyways, so yeah, we can. Well, we have to refactor this in some way. So, or I'm missing a step up here maybe. So let's actually go back. So again, I'm just this stream is gonna be double slit set inclusion, sets, and stuff of that nature. So again, literally breaking this down to its most simple components. This doesn't feel right though. So we're gonna bring this in according to De Morgan's laws, right? This is still wrong. No, this is still correct. So the problem I'm thinking of now is do we how do we say that we don't want elements of C to be in this? Because we only have X cannot be X is in A and X cannot be in B. But there's nothing saying that X cannot be in C, which is true because we are taking the union of these two things. So anything that would be in C that also exists in. Oh, I guess that kind of that holds then. But it's not the condition that we're looking for. Because anything that would be in A and C would exist in this set, obviously, right? Because it's only minusing things from B. But then I guess you could say things from B could exist in here. So that's not. So this has to be incorrect then. X is oh shit. X is in A, and X is not in B. This is not proper set notation also. This is just for brainstorming purposes. B and X is not in C. I swear this would follow De Morgan's laws, but maybe I'm wrong. Maybe let's try to solve this more logically. okay. So I had it wrong. I had the question wrong. Then, now we can apply De Morgan's laws, obviously. So, x is in B. X is not in B. And x in C. Now we're done. This is it. We don't have to really add anything else, I don't think. We group this together, right? But important to put these in brackets. Not that important, but now we can just say thus x is in A and x is in B, or x is not in B, and or we can say or, because again we're refactoring this, so we're just expanding this. Because all three of these conditions have to be true, but if x is an A, it's already a true statement, then well, I guess both of these still have to be true. Or no, sorry, the and would actually change to an or as well because of De Morgan's laws. So this would become or. So yeah, then either one of these have to be true. So and now you get obviously A minus B and A intersection C. Cool. Okay, now we can do the other direction. And this should be pretty straightforward. Let x again, break it down to very simple definitions. Thus, x is in B, and x is in A, x is not in B, or because of the union, x is in A, and because of the intersection, union, intersection. Cool. Now again, as we factored above in like the above direction, we can actually just go the other way and just say, we can simplify it. We could say x is in A, or we're going to put thus. Don't forget the and. Again, important to refactor some of these conditions. X is in A, and this is true or this is true. And either x is not in B or x is in C. And if either of those are true, then we're in, because again, either one of these are true. And now we have, pretty straightforward, this shows, I guess if you really want, you can say this too. Thus, x is in A, and x is not in x in B, and x not in C, which of course just simplifies to B minus C. This shows that A minus B intersect. I'm so sorry. Is a subset. So now if they're subsets of each other, then they must be equal. So therefore, okay. Next problem. That was 3. That was C. Okay. So first direction, where X be any element I'm going to skip a few steps here. Just because of the first statement. Now we can do the second statement. And this is not in B, or X is not in C. So I did skip a couple steps there, like putting it into Morgan's law and stuff, but yeah. I think that's true, right? Minus B intersection C, so if X cannot be in any elements in both B and C are any elements in either B or C are removed. So this statement makes sense. If you think about it, if an element's not in B, then it's already not going to be inside this intersection here. That's guaranteed, no matter if it's in C or not, and vice versa for C as well. So we can actually refactor this, right? We can say thus X is in A. I believe we can refactor this. I have to go blow my nose. I'll be back in one moment. Okay. All right. So how can we factor it to get to this? Okay. So thus x is in A and x is not in B, or x is not in C, right? That's one condition. And okay, wait. I think I'm doing this wrong. So we actually have a bit of a contradicting statement here, right? So we have x must be in B, but x cannot be in B here for this to be true. So if an element is in B, then this is always going to be false. And if an element is not in B, then this is always going to be false. So we can basically disregard any elements in B in regards to like this first statement here, because it's always going to be false for one of the cases. So the only thing that really matters is if the element is in C or not. And of course the element must be in B, because this statement must be true. So we write this as any element of x that is in A, because that's important, element that's in A, and any element, because remember, this is an and statement. So it's basically we have to have the element in B, but we cannot have we can just ignore the statement because this statement is always going to be false. If the element is in B, this is always going to be false, so we can just disregard it.